Hello, everybody. Welcome to this session, which is the basics of containerization as part of DevToberfest. We're at the end of week 3, and Kevin Musick and I put this together so that we could have a little bit of a beginner session. I know it's week 3 instead of week 1, but it's for those who may not be diving into everything to do with, what's going on with cloud native inside and outside of SAP. So we wanted to give you a little bit of a primer and show you what it's all about. I'll go through the agenda in a second. I'll share a PowerPoint and I'll go through a demo. Should have Kevin in the chat answering any questions that pop up while I'm talking. I'm going to try to go through this without stopping for about 30 to 40 minutes. So feel free to ask your questions. If we don't get to them during the session, we will follow up with you later. So with that being said, let me look down here and share my screen, and we will get going with the presentation. All right. Okay, so you should be able to see my PowerPoint here. Let me open this up. So the basics of containerization. I'm going to go through, in the beginning, the evolution of infrastructure and where we started with people that were running data centers and doing virtualization into then containerization. Then we'll go through why a container and what is the key components that you're going to be using. And then we'll wrap up with why is SAP talking about this? What are some of the things that we're doing in the container space? So in the beginning, we had bare metal. So you got servers, right? And it could be something you're running in your house. It could be something running in your company, in your data center. And if you think back to when things started being networked in around the 1990s to the 2000s, you would buy it, you would build it, you would have applications running on an operating system. Unix, Microsoft, Linux, different operating systems running in a server that was basically regulated to just doing what you set it up to do. If you needed to license it, you had to pay for that license annually and the maintenance that went along with it. You needed to also do patches and security fixes on the server itself and all the applications that are running on top of it. It's your responsibility as the person who was running that server in that data center. So everything was self-maintained. You had tons of control, but you also didn't have a lot of flexibility because you would have to tell everybody when you were going to take your data center down for maintenance. It cost a lot to buy this equipment. You own it and you can't let anybody else use it. So there are some drawbacks to doing bare metal as well as the positives of owning everything and having it under your control. Then you go into virtual machines. So with this, you're still buying a machine, and you're adding software to it that allows you to do the things you were doing on bare metal. So for those who've never done virtual machines and seen how it's set up, it's basically you have a server and a rack, right? And this rack of servers and power, it's a piece of equipment sitting in a data center that now is a bigger, more powerful computer that can run other computers inside of it through software. So you're going to have a hypervisor that says, I'm now installing Windows 6 times onto this one piece of hardware. The advantage to that is that you're sharing the processor, you're sharing the memory. You've got one power cord coming in, one set of RAID backup disks that are doing all your backups, instead of having 6 different computers that you have to set up from scratch. Now, you get a lot of OS choices here because you now can say, I'm going to have 6 versions of Windows running. Some are going to be different levels, or I'm going to have Linux running at this version. And these are the programs that need to use that. So a lot less hardware footprint is being taken up, and you're using less power because you have less power supplies coming in, but you're locking up machine resources. So if I build an application for DevToberfest and it's running in a version of Windows and I need a different version of Windows to run something else, I've locked up that one virtual machine to where it can't do other things. So the resources, the memory, all the things in the kernel are now being shared, but above that, the application has locked up those resources for the OS. So then we move into containers. After years of everybody doing virtual machines and having to maintain them and not knowing who's doing what, we now have not an evolution of virtual machines. What we get with containers is it's not infrastructure that's jumped into the next level. It's everybody writing for a different kind of kernel and OS. It's your applications are being written and they're running in a containerized application. You're still buying a machine. A lot more stuff's being done in the cloud now than on-premise. A lot of containerized applications, while they can be run on-premise, we find that people want to run their containerized applications across cloud infrastructure because you're getting that installed software, the maintenance, the security patches everything's done by your data center administrator. And if the data center administrator can say, everything is going to be upgraded by me, you can't change that. As an app developer and somebody who doesn't want to worry about security and migrations and patch fixes for a cloud or for a data center, I love that. I'm just writing an application and I'm putting it into a container for several reasons. Some of these are, hey, now I've got machines that are running in a cloud, but maybe I want to move from one cloud to another. Because of container standards, you can take your container and you can move it from one cloud provider to another one. This is that version of multi-cloud that we've talked about at SAP for a while. The next thing is a containerized application. It's self-healing, it's homogeneous, it's as far as from an operating standpoint, you know what you're going to get when you turn it on and how it's going to run. It's scalable, so we can take an application that needs 4 pods to run, and pods are groups of resources that are being used by an application. And we say, okay, I'm going to have these applications running in 4 pods. If one of those gets sick, has an issue, whatever happens to it, and it's not healthy and it gets turned off by the cluster, another is told to spin up automatically in the background. So your 3 running applications and 3 exactly the same containers will now have a 4th one join up to replace the one that went bad. So for a second, you would have 5. You would have one being turned off because it needs to be rebuilt, and a 4th that was just turned on because of something that needed to be done to make it work. And I'll show you later in a demo how we actually build clusters at SAP. And I didn't mention this, but it's way more complex when you break these things in multiple pieces. When you get microservices and multiple tools, and now you're doing reporting and analytics and monitoring and all these different things that go into managing containerized applications, we blew them apart into so many different pieces. An app developer would love that, right? Because they just have what they need to run their application. But maybe somebody who's in the ops part of DevOps isn't as happy because they have to operate across a diverse landscape that isn't as contained as a virtual machine landscape was, or in the old days, bare metal. So that being said, why a container? Kuber what? So talk about containers and Kubernetes. I'll show you where Kubernetes started in a minute. And the reason Docker's logo looks the way it does is the whale. It is the whale to represent the pods of whales, the pods of applications. And the little squares on the Docker whale back are to represent those container ships, right? And the containers that are on those container ships are standards. If I'm getting a container ship and it's leaving Amsterdam and it comes over from the Netherlands to New York City, when they load that container from the Netherlands onto a ship and then unload it in New York City, it's the same size. Now, inside of that, you may be putting information or product that could be completely different than the container right next to it. And that's the beauty of a containerized app in its simplest form. And it's a way overused analogy, but that's why people use it, because it's so simple to understand. If I want to put car parts into a container and then next to it, I want to put popcorn, it's food, right? Food could be more different than pieces of metal that go into a car. But these two things are going inside of containers that look and feel exactly the same from the outside, because everything at the kernel level, everything the infrastructure level below that is all built up to make the application function no matter what it is inside of that container space. And that's what you're doing. You're building your application to run. You're saying, I need Linux. Okay, well, Linux in this case represents what's at the little bottom sliver of that container and everything you need to run your application. And then the other containers that are near it, they may not be running Linux. They might be running some other version. It could be a Windows operating system. It could be tons of different things that are going on inside of these containers, but underneath them, they're all running in a very homogeneous way so that you can transport them and move them to different places. And that being said, we've got .NET, Microsoft, out there. We've got Azure Cloud, we've got Google Cloud, we've got AWS, we've got Ali Cloud, Jenkins, GitHub. All these players are coming in to move things around between data and to move these applications around between the data centers and the different places they're operating. If you're a fan of Star Trek: The Next Generation, which I am, so there was a guy named Q, and he used to mess around with the cast members and the Star Trek, and he would at different points make them have different challenges, things they had to do. And one time the captain of the Starship Enterprise got into an argument with Q, and Q snaps his fingers and their ship is blown into another part of the universe they'd never been, and they interact with the Borg. And the Borg assimilate things. They're cyborgs. So it's a biological mixing with the technology, right? It's a cyborg, humanoid computer. And the Borg assimilate things in. And these cube shapes are the efficient way that they build and maintain their spaceships. So Project Borg was the predecessor to Kubernetes. And I'll show you a screenshot in a second of the actual website where you can read up about more of that. If I jump out here into my website, you can see here Borg was the predecessor to Kubernetes. Google was building up and doing data center stuff, and they were like, hey, we got a lot of people using our applications, web browsing, and a lot of resources in our data center is being wasted on virtual machines. Is there a way when somebody's using an application, and the biggest example of this is Gmail, and they're opening up their email browser, the front end is loading up all the security and identity information, and then it's grabbing the back end stateful stuff, the things like the stored records of the email. How can I make the stateless, which is the person logging on, merge with the stateful on the back end without wasting resources? So if you read this blog post about Borg, the predecessor to Kubernetes, you'll see how it was a way to take all the different stateful things and stateless things and have them work together, where when you were done with something like a web page or an email browser and you close that client down, everything at that part of the stack was then gone. But everything that you had saved, all of your database information for your email records, that was living in a server somewhere else. And when Gmail used to give you so much storage, like this is how they could do that. I wasn't a Google employee. I don't know for a fact, but I know when I was a first Gmail user, they were giving you tons of storage compared to the other email users out there. And the way that they could do that was because people weren't trying to use a lot of email to store stuff. There weren't shared drives in the cloud at the time. It was a way to entice people to not run out of space for their email browsers and their email accounts. And when you open up your browser window and you close your browser window, that's when you were opening and closing a container. So anyway, it's a great thing to read up on. There's also in Kubernetes, you can see tons of different things, as I mentioned, that make it more complex. So service discovery and load balancing, storage orchestration, automated rollouts and rollbacks, automatic bin packing, self-healing, secret and configuration management. And this is things that Kubernetes does. What it does not do, you can read through the different types of things that, are included in a platform as a service, that Kubernetes doesn't do that. It's not meant to be at the bottom level, like I was mentioning, and running your OS and having all that kernel stuff that's built into the hard drive to operate the operating system. It's meant to be an application layer and the things that go into making that application run more efficiently. So it doesn't deploy the source code. It doesn't do security patches to the operating system, things like that are running underneath it. Anyway, great stuff here from the Kubernetes project, kubernetes.io, where you can read all about what Kubernetes is. But Kubernetes has a lot of different complex things that are going to start to happen when you want to do monitoring and you want to be able to see different things that are going on from a reporting standpoint. And you start to realize, wow, I need other things. And that's where the open source community came in. And they started building because Kubernetes is open source. And they started building other open source things for cloud native people. And this is where the Cloud Native Foundation came about. And they started looking at all the different components that they needed to actually make it more efficient. So I'm going to go now back to the slideshow real quick and show you what SAP is talking about. So why are we talking about this? Well, if you look at Steampunk, which is ABAP running in the cloud platform, so BTP, we've then got CAP, Cloud Application Programming Model. We have our front end OpenUI 5 that we use to make Fiori applications and the framework that connects to the SAP backend systems. And then at the bottom here, I've got Keema and I've got Gardner. So Keema is our layer above Gardner. Gardner is the Kubernetes. It's where we're growing clusters of Kubernetes. It's where we're growing those things that we call pods in traditional Kubernetes. And it's where we're building out the framework and saying, hey, I'm going to have Kubernetes running. I've got everything that I need to deploy my applications. But what if I need some other stuff? If I need to add in Helm and I want to do different things with reporting and charting and monitoring and all these different open source projects that are out there, and my microservices need to be managed in one spot. That's where Keema came about. And Keema is an open source project as well. And what we're doing is we're seeing that there's all these different things between Keema, serverless runtimes, Cloud Foundry, ABAP, and you got the Cloud Application Programming Model and ABAP that I mentioned earlier sitting above that. And then you got to have things like a tooling to do front-end development and application development. And all these things are needed to make containers work. So let's jump out and look at this from an SAP intelligent enterprise, or evolved vision. You might have seen this slide before from SAP, but at the data center at the bottom through the technology to the intelligent suite, it's all about getting business decisions made more quickly using applications. And if I show you how we build up all the things that go into making these applications connect to each other, you'll see how SAP is using this. So you're not just doing something from a standpoint of I've got to build this and maintain it myself. What's my levels of service that I'm going to get, my SLAs. So with Gardner, I can go in here and I can build project clusters and maintain them. So I've got AWS set up already. I built this one to be what I call Devtoberfest 1. I can see that its purpose is evaluation. It's right now a hibernated cluster, so I can save money when I'm not using this application. It's still built. The cluster's there and ready, but I can have a management console like Gardner put it to sleep. So this is what SAP is doing underneath the layer of things that you see from the business technology platform. And this is available. Gardner is an open source project as well, but we maintain this stuff as part of what's inside of BTP with Keema. So version 1.24.6 of Kubernetes is how I built this. And then I've got my different API servers, I got my nodes, and I've got my system components. I've got shared secrets and things that I can do to get into this cluster. So if I click on the Devtoberfest 1 here, I can see all the different details that go into this, but I can't open a terminal right now because it's asleep. So let's go down here and wake this one up. So let me go over here. All right, so click here. Wake up the cluster. Now this one's going to wake up. While it's doing that, I'm going to go through and I'm going to build another cluster for you. And we'll call this Devtoberfest 2. For this, I could choose a different version of Kubernetes. If I wanted to, I could say this app that I have runs on .5, not .6. Is it for evaluation, or if I had a production cluster here, I could choose a different cloud provider, Azure, GCP, OpenStack, AliCloud. So these are the different versions that are available to you as a Gardner user. And I can then go through and see and more secure alternatives, enabling static token queue config. I can turn that off or on by clicking that box. I have my shared secret for AWS that I set up as part of the setup of the administration of Gardner. I'm in here now as a cluster administrator, not as a Gardner administrator. And the reason is so I'm not allowed to break the entire system. I got Containerd as my runtime. If I wanted to, I could choose Docker for that here. I could change that. So again, Docker's out there, Containerd. There's all kinds of different places that you can be building your standard application to run. Then that's where the open source community is great, because you can take different things to the community and try them out and use them. If we see that they're stable enough, we put them into our open source project, and then that makes its way into BTP later. And that's where you get your full service level agreements from us. So here's my auto scale where I talked about, scalability and self-healing. I could have this one scaled to be 2, and the maximum would be 3. So it's always going to have a minimum of 2, max of 3. I can do different things like that, so that if I've got more users using my application, I'm running a campaign, I know I'm going to have more people coming in and hitting this application. I don't want them to get, locked out and not be able to access it. And it returns that the server's busy. And the way to avoid that is to have your server scale to what you think it needs to be appropriate. And this is where you're protecting yourself from overpaying for resources at your cloud provider. You don't want to have unused resources that you're locking up, because then you're paying for that. So you've got to figure out and estimate what you're actually going to need out of your cloud provider. So scrolling down here, I can see I've got a maintenance time window I can set, and then days of the week. So I hit create down here at the bottom, and it's going to say, yep, failed to create it. Why did it fail? So something's wrong. It's forbidden quota limits. So I've already got that one cluster running, right? So if I go back to my cluster screen, I'll see the one that I've got. This is the one I'm allowed to maintain, and now it's going to be waking up, and I can go in and actually do stuff with it. Let's see the hibernation status. So it's still waking up the cluster. So if we go back in to look at the cluster here, I can see that I've got a status of reconcile succeeded. That's because I went in and woke up this cluster. It was in hibernation mode. And now I can go in and see, I've got a terminal. If I want to go in and actually use my terminal to go in and do things instead of being in the GUI. And this is basically just showing you that if you want to maintain and do things at the command line level, you can do that. You can adjust YAML files, which are the instructions basically to how your Kubernetes cluster is going to behave. So this is, again, a beginning session. I'm not going to go in and go too deep into what containerization is. This is just the introduction to it. This shows you how SAP is doing some containerization things. The next tab I have open here is to show you Keema. So with Keema, it's another project, like I mentioned, Keema project, keema-project.io. And it's basically going to show you the Keema runtime, Keema dashboard, all the things that go into maintaining Kubernetes and those other components that are out there. So when we use Keema, we're actually running it inside of our business technology platform. So the Keema environment is running on a Kubernetes cluster created for that sub account. So you're not living now in the space of everything that's SAP, open source away from SAP. You're now living inside the SAP business technology platform. And with that, you're going to start to see that Keema gives you a cockpit of its own underneath BTP. So I can go in and maintain my subscriptions, instances, and environments. I've got my Cloud Foundry, Keema, and other environments. And this is where I can go and set that up inside my business technology platform and start to deploy applications that need to take advantage of these containerized functions. So we started with a data center world that was all self-maintained. We moved into a hosting environment. And now we're in an area where a developer says, I don't care about all that. Just give me a space to connect to my SAP data and make an application, use microservices and do eventing and send things back and forth between different systems. So I would then get my Keema console and all the subscriptions that go along with that and be able to open that up and actually go to a dashboard and see Keema. So this is going to try to open up in the background. It's not probably going to go all the way through and have a production system because I haven't set everything up against it. But it's got security in front of it, which is great. So I can then see that I've protected myself from having open source consoles out there. I've got everything maintained. I use two-factor authentication from an SAP service. You might use a different kind of SAML or whatever to log into your Keema systems. So that being said, I will now go back to my PowerPoint and talk about why this is important. So it's all connected. So in an application world, you're building applications and you got other applications from SAP and non-SAP environments. SAP itself, we've got HR systems from SuccessFactors. We've got C4HANA for commerce. We've got Concur for travel and expense management, Ariba for purchasing. You may have one or many of these or other systems like them that are going to be based on a user needing to do something. And that user doing something is going to trigger some event or something that talks to another system somewhere else. With Business Technology Platform and with Keema and the serverless runtime, Cloud Foundry runtime, ABAP, Steampunk out here, you've got different SAP systems that are all talking to each other in the cloud, to all of our other cloud applications that are out there. So in a sense, you've created a world where you can do all this on your own. You can try to build it. And if, in my opinion, you tried to build a system that did all of this, you end up with something that looked like Business Technology Platform to connect it all. So you could try and build and maintain your own version of it in the containerized world, or you use something like SAP's Business Technology Platform. And there's other middleware players out there that have a platform as a service. And the idea is to connect all these other things to your users and your data in a secure, scalable, repeatable manner. And that's the point, right? Is SAP wants to be there to help you with this. And there's so much to learn and so much to do. And it's not just a shiny new object anymore. These are things that have moved into production. People are doing this. So try to get educated. And this is where I make the pitch for not only DevToberfest, but for TechEd. So TechEd is in November. We're at the end of week 3 of DevToberfest now. So we're about a month away, almost exactly, from TechEd. It is a global virtual event, completely free to attend. So learning.sap.com/TechEd, get out there, get yourself more educated. You might be able to, get a different role within your company, learn some new skills. At the very least, DevToberfest is about earning points, right? And you can earn points towards our competition where we have some prizes, not the least of which is 10 all expenses paid trips to Disneyland in California for our customers. So there's rules out there that have been posted in our DevToberfest groups. Please read up on those. And if you're looking at the points and completing tutorials, I want to mention that there is a special kind of a hidden bonus if you register for TechEd. So if you're already registered for DevToberfest and you're doing the competition, we will see if you registered for TechEd based on the badge that we give you for being a TechEd 2022 registrant. And we'll give you, it's a 4-digit number. I don't want to give away, but it's a number that's important to SAP. So anyway, it's at least worth 1,000 points, but I think it's a little more. So you get these points just for registering for Tech Ed. I hope you attend both days, watch all the great sessions. If you can make it out to Las Vegas for the hands-on sessions, those are great. You get 2 learning labs on site, and you also get to see the keynotes live. So anyway, that's my pitch for Devtoberfest. Kevin and I really appreciate your time. If you need to contact us, here's our information. And as always, we're available during Devtoberfest in our SAP groups, and we're available on social media and anywhere that you need us. So thank you so much for attending, and I hope you enjoy the rest of Devtoberfest.